How's it going, everyone? Eul here, again, looking at the front-end system design, and today's video is gonna be a more practical and heavy code video, because after we were able to understand all of the theory that I'm going to describe quickly. Now we need a more practical sense of how do we make sense of all of this theory, and then as a UI specialist, so I recap all of these fundamentals. How can we now that will allow us to build these complex web applications, right? So the question is that why would I need to actually take a look at this? Well, because if you're going to provide this as a service, and if you see yourself as a business, okay, so for example, pretty much like sport teams or companies or athletes. So when you see yourself as a business, as someone that can provide value, you then do things to actually move to that goal. And that's the reason why I actually are learning all of this concept, be able to describe these fundamentals, and when it comes to provide my service to solve specific use cases, I can do that in the most blazing fast and performant way possible. So yeah, pretty basic of that. And for that, well, because this course is taught by Ifni Ray, a software engineer that previously worked at JetBrains and then currently now at Meta. Okay. The idea of this is to see how we can now, by understanding the fundamentals of UI, of front-end system design, as a UI specialist, a lot of the time those fundamentals allow you to build this complex or scratch. By understanding the fundamentals of front-end system design as a UI specialist, you can now build is more complex web applications. Not only that, but when it comes to maintain, that's where we look at another particular topic, which is from the UI enterprise UI development, as a way to understand and to keep up the pace when it comes to look at what are the things that we need to, as a way to maintain the code base, as a way to provide value to others, because that's what it's all about. And that's the reason why I actually see myself as a business, not only as someone that can charge, which is in this economy, in this way of, or in this life, about in this human life, is how can we actually interact each other without killing, in how can we collaborate that. So as long as you provide value to me, great. So that's why athletes, they provide value to their consumers, to their viewer, to the observers. Okay, it's pretty much like musicians, artists, as well as now sport teams. But all of this is now they are good at what they're doing, and they're providing some value to the others. Most likely is to emotional value. All right, is the feeling of something, not only to solve problems, but also to make them belong to something, or to make them experience something. I think this is one of the reasons why actually I'm looking myself as a business, totally, because this is a way of how you can now be valuable to yourself and for the community. And when you realize that the best things that you can do, especially if you're not gonna kill yourself because you're too coward to do that, which is something that a lot of existentialists, writers, over the centuries. So from Kierkegaard and Schopenhauer, and then now more recently Nietzsche as well, and more recently Camus, Jean-Paul Sartre, but most likely Camus in my case. Jean-Paul Sartre, I got a strong feelings about him because I think that is he need to do squats, bro. Even though that you are ugly, when you maintain physical health, Simone de Beauvoir will want to rape you. But in any case, but most likely with Camus, all right, which talk about a very interesting topic, which is what is the reality of life. Why do you live a life when you don't hold any of this religious or spiritual or philosophical tools that allow you to live a life accordingly, or at least to be functional, all right? And I think that's what a lot of these societies are facing after the Second World War. They live in this period of abundance. Latam perhaps not that much. South Korea, Southeast Asia, I don't know. Not to mention China or South Africa. But at least the developing countries actually live a bubble or a period of this abundance that no other ancestor, father, grandpa, grandpa has faced before, and they are real challenge. And most likely they are now psychological, they are inner challenge that we have to face, and that's what we are here, right? So again, I know this was something that we have to cover, go beyond the scope of this course, but the thing here is that a lot of the time, when you are true to yourself, when you want to dive deep into why you do the thing that you do, especially when you are looking at why you are actually working for a company as a software engineer or whatever field, you need to know is the fundamentals. You need to know how do we get here, and part of that understanding, it also is closely tied to the life. So because of that, once you understand how do we get here, you will embrace complexity. So that's what we are here in today's video. So way to quickly describe is this observer API, which is to cover specific business use cases, the intersection, the observer, and the resizer, and that's what we're gonna do here in today's video as a way to actually how you can now create this components and how you can make use each one of them for their particular use case. So for that, let's begin, shall we? So first, it's important to understand that how you are going to what is the platform that you're going to build your UI elements, which is of course is on the browser, and what now is the way especially of building front-end systems, right? So we need to look at what an application means, what is the anatomy of an application, what is made of the front-end, API, and back-end. This course is only focused on front-end because this is the service that I want to provide to other companies, all right, and then slowly migrate to backend, right? So for example, they are backend. Let me see if that actually is something that they mentioned here. Where is it?
Application, like how we communicate.
Exactly like this, right? It's an introduction to backend architectures. That's right. Evolution of users and backend system architectures. Yeah, merchants of complexity is this one. Merchants of complexity, totally, man. And then another very interesting topic here that we can take a look after the backend architecture. That's right. But again, here what we care about is the front end. Okay. And you can combine that with front end and back end. Again, the TLDR of that is that you must provide value. Period. Period, my friend. Period. As an employer, as a consultant, you must provide is value. So that's why we're focusing the front end first initially, and what are the areas that we are responsible of, right? So pretty much like Iron Man, okay, where they have now all of this specific skill set and tool sets, okay, that can act upon that. Pretty much we are now here on the front end, right? So this is all of this area that we are responsible for, that we need to monitor. So the API connections, how do we communicate to this server or to the API specifically, as well as the UI or the user data management, UI data management. Hey, how are we going to store the data? How are we going to manage the data in an effective and efficient way? And also we add is the user interface interactions. What are the most common user interface that when we are building our applications are needed to cover those use cases? Okay, so for example, for analytics or for loading components as we scroll or dynamically doing that, perhaps we want is to now is allow the user to edit the content for text-rich editors or for drawing things. Perhaps they want now is to look at how this charging libraries across different devices, especially on mobiles, right? And also how you can now provide an experience of each one of those devices with resized objects, right? But all of this, okay, use cases are now we are responsible of that, okay, as the UI, the user interface interactions, and also we are responsible is for how much data and how much assets the user is loading. Okay, so how much data we're sending to the how much HTML, CSS, and JavaScript fonts and image that we are sending to that, okay, and how we can actually find a way for guarantee that on low power end device we can provide is the best experience as much as possible, and even for low coverage or low call coverage, or poor areas with low connectivity. So that's quite interesting, this challenge, and understand each one of them, that we can think of each one of this area that we're responsible, like a laptop that we have in front of us, all right, that we can now actually do that kind of thing. Another is, one way you can think of this is, yeah, the laptop is a good quite analogy, right? You have now 4 monitors, right? You can have now is to be very productive and efficient as much as possible, right? So yeah, pretty much is this. So that's great. That's great. That's powerful. When it comes to actually is know what are the fundamentals, the core fundamentals, which is part of the this course. We're gonna look at the core fundamentals as well as the DOM API, and then how we can now use some of this web API to build some complex UI. Actually, get our hands dirty by building one of those patterns like virtualizations, and then know how can we manage the application of or the application state design, as well as how we're going to communicate to the API, the network API, and last but not least is how we're going to manage those assets. And the last section is that how we're going to combine all of these different pieces together to actually build and feature on the front end. So, core fundamentals, right? Because the browsers now, the way how the browser treats elements, HTML elements, when you are adding the style, is by putting a box using CSS. So in CSS, everything has a box around it. So once you understand how this box works and how they interact with other elements, a lot of the time that will lead you to write is complex UI. And that's what we look at, the box anatomy, the components of that, the content, the margin, the content, the padding, the border, and the margin, the property of these boxes by the size, which is inherited or restricted by applying certain rules to that size, and the type of boxes. You have now inline, block, and anonymous, and how now each one of those type of boxes had a set of rules that now they participate in something called as the formatting context, where the whole point of this formatting context, whether it's block or inline or grid or flex, is that now provide is an isolation, so all the elements don't affect how these elements will interact. They isolate these elements inside of this formatting context, which is great because it's also scalable, since now by defining this formatting context, you can put and design any layout to that. You can define is whatever property that you need here, whether it's block or inline or flex or grid, and each one of them will have now set of rules that apply of how this element should behave, which makes them scalable. So as things started to make a lot of sense, and now that we know how we can actually is creating this formatting context, and when it comes to understanding how the browser put all of this context or these elements on the screen through the position system, which is follow the normal flow, all right? A lot of the time when we want to now put elements outside of that normal flow, which is putting elements outside from the from top to right, from left to right, and top to bottom, right? When you're using properties like position absolute, relative, or CSS transform, you're creating now an stacking context. So these stacking contexts are great because you can now not only isolate your particular set of elements, HTML elements, and how they're going to be displayed, but also you can perform some optimizations to this stacking context. because the thing here is that when you change the geometry or the position of each one of those elements, you are triggering something called as the reflow, which is the mechanism that the browser is one of the phases of the browser mechanism that when it receives the assembly line, is the browser assembly line for transforming is HTML, CSS, and JavaScript into pixel on the screen, and the reflow is one of them. It's a one phase of that. So you have now is the DOM. Okay, so you have now the DOM in the CSS object model, which is something that the browser actually parsed to that. Then once it merged that information from the HTML and the CSS object, it create now this render tree where it contains all the information but doesn't know where it's going to be. It doesn't know the location, the position, and the geometry of these elements. That's what we have now, this reflow phase. And they call reflow because anytime the geometry or the position of those elements change, it needs to recalculate, need to reflow. The normal flow needs to be calculated, the reflow. So this is triggered usually by JavaScript when you modify one of these properties that I mentioned before, and it trigger now this layout phase, which is, well, now how on that particular layout here, right here. So on that particular phase, the reflow phase, it has now the layout, which is, well, this phase is now tell the browser how to calculate the geometry and the position of all of these elements. There is a very interesting video out there, so you can see how that happened. Okay, like this, right? Is that now how the browser is actually putting all of these elements and calculate its geometry, okay, in this case for Wikipedia website, right? So it's now calculating all of the geometry again for all of that, as well as the position, and there you got it. This was actually quite interesting. Oh, what the F? Okay. This is actually quite interesting here. It's actually very, very interesting. Very, very interesting. It's and that was like yeah, and that was the Geeko reflow. This is a visualization of that. Again, you can take a look at that. It's actually quite interesting. And then now, because if we don't use certain properties that doesn't modify the position of the geometry of those elements, for example, a CSS transform, we don't trigger the layout. Therefore, we just only pass through the paint and composite layer, right? So now this paint and composite layer is that, well, now the browser knows all the information needed as a way to paint this on the screen. Back in the old days, they used GPU. All the browsers use GPU to do that, and not to mention to calculate is the composite layer, which means that because you provide all of these stacking layers as well as the graphic layers, so you have the render layer and the graphic layer, okay, now the browser used CPU for that because, well, back in the old days there is not everybody have access to graphical cards or GPU, but now modern browsers actually make use of that, which is quite interesting. And you're gonna see that a lot of, even though those mid and low power end device actually now a particularly dedicated GPU to say, all right, Now for us it is time to actually do this optimization, so we can now from the browser perspective use this resource, right? And this is how now the composition layer works. This composition layer is how now the browser creating all of this stacking context as a way to render them and show how those will be look like. All right, so this composite layer is made of the render object, which is a relationship of one of the HTML elements. The other is the render layer. So when you use, for example, position absolute, or when you change the normal flow of an element, actually create this render layer. Okay, this is stacking context. And when you need to use now is more CPU intense task, okay, such as video or 3D perspective or canvas. Now the browser say, hey, let's go to create now this graphic layer. That's interesting. You can say render layer on the browser, as well as the graphic layer browser. Okay, graphic layer APIs reference. Now what I'm talking about is the browser here. Or Chrome. Graphic architecture, accelerated rendering in Chrome. Accelerating rendering in Chrome's rendering engine. Oh, exactly, but this is rendering engines. Are part of the web browser that transform HTML, CSS, and other resources on the web into visual representation on the screen. Blink, Gecko, WebKit, and Trident. Okay, browser engines. Big fatty caveat from down to screen. But this is very old, bro. But this is very old. 2013, bro. In graphic architecture, GPU process, Chrome compositor, Aura and WebKit, render process, and browser process. That's quite interesting. That's quite interesting. The browser process and the render process. Aura graphic architecture, the Chromium projects, and then you have now the Chrome compositor that talk to the GPU process. Pre-layer tree unification. How relevant is this? Do you know how relevant is this? Because this is Aura. Design documents, general architecture, UI framework, GPU accelerated composite in Chrome. Okay, the DOM tree that creates the render objects, where now it creates the render layers. And then the graphic layers. Okay, this is now explaining is in this. Sandbox application client. You have the commands, and now how, because all of this application is loaded in memory, they can talk to the GPU process as well as the IPC, and the command buffer, and you got now the render process. Sandbox application client, this is the command that is going to make use of this. And then you got is compositor SHM, WebLG1SM, WebLG2, pepper like that. So yeah, it doesn't dive too much into this. Okay, it doesn't dive too much into this. From here is in this document. GPU accelerated composite in Chrome. GPU accelerated composite in Chrome. The composing forest, and now that we briefly covered the data structure in Blink that link to them to the compositor. Okay, it's because they have now this compositor. Okay, so they have now this compositor, which is the, oh my god, they have now this particular way of how they compose this one of those layers that talk to the render. Okay, composite layer, how the browser does, how does the browser use the GPU? Is that by doing all of this composite layer, the render layer, the graphic layer, then when it compose that to talk to the GPU. Alright, but the whole point of this is to understand that this particularly, all of this concept that I mentioned before, the type, the boxes, the property of the boxes, the size, and all of, the size and the properties, the size, right? The size and the, the size and the, the size and the type of boxes. So you have now is the inline and block, and how they now participate to something called as the formatting context, which is something that I mentioned before in the utility of that. And when it comes to know when the browser is going to put all of these elements, and when you want to create elements that are outside of the normal flow, so we to create more complex web UI to satisfy user expectations or business use case, this stacking context you can use as a way to improve is the performance. It means that you can now talk directly to this layer and say, hey, I want you to now is use the CPU, one, and second is I want you to now is exactly not only use the CPU but avoid to trigger is or to use now the browser, the render process in the most effective way possible, right? So why we want to do that? Because when we need to actually interact with the DOM, which is something that we are looking at this, when we need to interact with the DOM for writing our own low-level libraries, this is very specific to people that works on frameworks like Angular, Vue, and React, and Svelte. Okay, they need to know is all of this intrinsic, the intrinsic nature of that. For example, when I have now built a DOM management or virtualization, or perhaps you want to write as a component that actually needs to interact with the video elements or your own charting engine, or you want to just write on a portfolio with a minimal footprint. Okay, so all of this stuff, right, that we create here through by knowing it's a DOM API, okay, we need to look is, well, what are the DOM that is not exclusively to JavaScript. Other language can use that, for example Python. The DOM API here is when you are using JavaScript, it exposes you some global objects that you can work with. So for example, like the window that represents the screen, the document that inside of that you have now is the head, the body, and also you can now is through that object, to the global object, you can interact with the DOM. And to interact with the DOM, we need to know is the structure, the class structure. So we got is, well, it all starts with the node, that is this abstract base class, which is act as a blueprint for others classes. Okay, so for example, we have the text node solely for adding content to that. And you have now is the element that extends from that, and these elements because this is the base class from all the type of elements. So for example, like HTML elements or SVG elements or any XML elements. It also we have is from the node is the HTML document where we have now access to the DOM, to the window object. Okay, so this is the structure and how it makes sense when you're now going to operate to the DOM. For example, querying data. So you have now 4 methods: get element by ID. Things are actually the read, the time, and memory cost is constant. So you get that at once because it's pretty much like reading a data on a hash or accessing the data in a hash map. We also have this other method like get element by class name, get element by tag name. This return is now is in live collections, an HTML live collections that it's going to traverse this DOM tree structure using its DFS and then a hash. So initial queries to get that element using the CSS selectors. It'll take time, or in this case is using class, right? It'll take quite a bit of time, but then the read cost is, if the query is the same, the read cost is actually linear, right? What is the trade-off of using that? This has been a legacy collection that anytime you modify is the elements inside of that, you are triggering is now a reflow phase, which, as I mentioned, doing that now actually is, if you do that recurrently, or you have a lot of elements that actually are depending on that, you're triggering a lot of this reflow phase, which is something that has a significant performance issue, right? But this is one of the disadvantages of this, right? So even though that the memory cost is low, all right, the time complexity, especially if you want to iterate through these live collections, now chances are that you are going to need to iterate through that in quadratic time, so making now horrible. So that's what we have now. This another things called query selector and query selector all, where now instead of returning is a live collection, it's gonna return is a copy of this element. So this, when we modify is the elements here, it won't trigger is reflow, which is gray, okay? And now the time complexity, for example, in query selectors is linear time, almost linear time, the time complexity. at the beginning perhaps it's going to depend on the query itself, the selector query itself. So the read cost and the memory cost is blazing fast. If you use a combination of the DFS, hey, I'm going to traverse these elements, and once I get that, I'm going to hash that, or I'm going to memorize that as a way to prevent some computations. And similar to the query selector all, where now this return is a node list of elements. The TLDR of all of this is, it is important to understand that what are the methods that we can use as a way to query elements, and what are the performance optimizations that we can do that. So the TLDR of all of this is that use ID for core components, and use them as the starting point for a subtree that you want to work with, and simplify is your selectors, right? So that's quite interesting. That's very interesting. This is when we want to query, best practice when querying elements. When it comes to adding or removing elements, the story here is actually horrible, because inner HTML and inner adjacent HTML, both of them parse that. When you parse that, you actually take time to process that. So the performance is horrible, okay, and or the impact performance here is extreme. But that's what we have, for example, is the append child as a way to do that. And once you do that, of course, because you're modifying is the DOM, then you're going to trigger is this reflow phase, and then we remove the element for that. So finally, let's actually is now do the exercise. So for example, is this one, right? So we're gonna do this exercise, right? So this is our simple HTML. One of the things here of this is that because as a way to now is understand how can we get these elements. I don't know if you can. No, yeah, you do. I think you do. Yeah, you do. So using all of the things that we already know, we define here is, well, get element by ID for a container or the car template, that they act now as the core components and the starting point from where we're going to now populate is the data with dynamic data, right? So we use now template here, which is part of the HTML that say, hey, instead of actually immediately render this, you're telling to the browser, hey, I don't want you to immediately render these elements that are inside of this template. I will do that at runtime with JavaScript. Okay, so these elements actually is not present on the DOM, or at least the browser is not considering them part of the DOM when it comes to re-render things, and we can use now the template as a way to actually get that and start working with that. So what we're gonna say, since now the card template here, so since the template now has a particular API, okay, which is the template, okay, so the template has a particular API, right? And because elements serve as a mechanism for holding HTML fragments, which can be either used later via JavaScript or generated immediately into Shadow DOM, okay? So now this is the use cases for that, okay? So yeah, this is the attributes here. avoiding document fragment here. But the thing here is we want now is to not only get that element, say don't get element by ID, but we say is these elements include the global attributes plus this one, right? So because it's also contained is this, all right. All right, so because this HTML element template HTML element serve as a mechanism for holding HTML fragments, HTML fragments or HTML elements. Let me actually take a look at this. So HTML elements. HTML elements. HTML template serve as a mechanism for holding HTML fragments. Okay, it's like document fragment. Alright, so this is a way of how you can hold this document fragment. Okay, so because of this this document fragment exactly, because it's now this is part of the document fragment. Okay, so the thing here is that we want us to actually get that element. We already got that element here on the template. Okay, and the thing here is because now this template that it return us is an element here, but this element that it return is a document fragment, if I don't lose my mind. Okay, like this HTML template element. Exactly, it makes a lot of sense. HTML template elements that is now part of the HTML, is an element, is a node, makes sense. Okay, now it's a read-only document fragment which contains the DOM subtree representing the template elements. So because of that, and here we want is to actually is get some couple properties. Okay, from that, for example, from the template content. So template content, which now actually is this element, but we want now to know is we want to get is this reference, the article here. Okay, that's why we use this now the first element child. Okay, like this. First element child from this element. So from this template that has a particular interface where now is on the content where you're gonna hold the element or this document fragment, but we want is to get is the first element child here. Okay, now since this first element child is an element, all right, now I want is now I want is here to define this as the article. Okay, this will be now the article. Okay, and I want you to now to get this from this article saying document query selector. All right, or in this case it's not document, is the article. Okay, article query selector, because after all this is an HTML element and we're getting here an element that actually exposes that property of the get query selector, right? Slowly but steady things starting to build or add up. So article query selector here we got is this, and we want now is the because here we can pass is now a selector. Okay, like this query selector, because here we can pass is selectors. Okay, string must be a valid CSS selector. If it isn't, syntax error exception is thrown, right? So we can choose here the selectors. It actually doesn't tell me that. CSS selector string. CSS selectors. That's right. Oh, and XPath. Selectors model define a pattern for selecting elements with CSS rules that apply. It actually doesn't mention. Okay, guides, selectors and combinators. Selector structure is this one. Explanation of that. Okay, this is selectors and combinators, type of selectors. There are over 80 selectors and combinators. You gotta be freaking kidding me. CSS selectors can be grouped into the following category based on the type of elements they can select. The type selector select all elements that have the given node names. For example, div will select all div elements, and inputs will match any input element. The universal selector, denoted with asterisk, is a special type that selects all elements. Class selectors select all elements that have the given class attributes denoted by class. Okay. I match everything in combinators. Descending. Okay. Oh, okay. Again, this is actually recap of this CSS selectors and combinators. There are more than 80 type of selectors. So you got the basic selector, the type selectors. Okay. Matches element by node names. Okay, in other words, it selects all elements on the given type with a document. So it matched that for in namespace. Okay, type selectors and class selectors, right? Which is now is based on this. All right. This is as a way just to recap how we go. What are the CSS selector syntax that we need to recap, refresh? So for example, like basic selectors, you have now the type selectors. That actually is the way of how you can get any elements on the DOM to query that element in CSS, as well as the class selector, which is denoted by a prefix with a period, with a dot, right? The ID is using now as the hashtag. Okay, and when combining a type of universal selector with a class or ID selector to create compound selectors, right? So compound selector or combinators here, you have now is descendant combinator, child combinator, subsequent sibling combinators, next sibling combinators, colon combinator, and namespace separator. Okay, the namespace separator is another combination that is used generally in conjunction with the namespace as rule. This combinator is denoted by a single pipe character. It limiting type selectors and universal selector to a specific namespace. For example, by defining a namespace such as this, you can include selector that target element nested in SVG namespace only. Declaring SVG or anchor will match links within SVG and those in the rest of the document namespace for that. But the fancier you get, the less performing it is, right? The fancier you get, the less performing it is. Attribute selectors. The way of how you can select that is by typing is the type of that and pseudo class selector, pseudo class elements selector as well. This is just a way to recap this, but what we care about is the type of selector and the selector structure here. So you can refer a simple selector, compound selector, and a complex selector. So where a complex selector is contains more and more elements here. Selector list, which is great, and relative selector. The whole point of this, okay, is to slowly but surely make sense and understand now how you can do this. So here is a reference to the here's a reference to the CSS. Here's a reference to the CSS selector structure. Okay, is this one? Okay, refresh, okay, or recap of CSS selector structure and that kind of thing. So this is great, this is powerful, this is awesome, because now with this query selector we can say, hey, let's going to go with a class here, and when we're saying this, we're mentioning is I want now to use is the type of the basic selector class selector, right? Not the basic, which is directly a target, particularly HTML element, but the class instead. Okay, you can also use the ID, but in this case it's the class itself. So I want you to now give me is the car title, for example. We are using is now the separator list. Okay, a given element is said to match a selector list when the elements match any at least one of the selector in the selectors. If any selector is known for given selector, list is invalid. Known for given selectors. Okay, for given selectors. Okay, but in this case it's a selector list, right? The selector list that actually selects all matching nodes. A selector list is a comma separate list of selectors, right? So here, this is not going to find is the first one. I want you to know is return me a list of nodes. Query selector all, when you find that has is the car title, as well as the car body. Okay, and from there we're gonna get our element here as a node list. So we're gonna have this now the title as the body elements. We're now here is we take a look now at the query selectors all, right? since we are receiving now is a node list, okay, a non-life known list containing one element object for each element that match at least one, exactly, containing one element for objects that match at least one of the specified selector, or an empty node list, okay, which means that we are actually getting is this, and the node list is just a collections of collections of items here, which is this. You can actually get access to that for each key, because after all this is a list. All right, and we are returning is a non-life collection. All right, which means it's our copies of elements. And here on the title, we can actually say, hey, since this is now is an HTML element, so HTML element here. Since this is an element, because that's where we are receiving elements. Hey, I want you to know is, let me check if you actually have something called like the text or the content, some sort of that. Instance property, instance methods, events, inherit from node, event target. Is the node contains a particular property? The parent text content, yep, the text content here that inherit from the node, where we can say, hey, title.text content, okay, which is now inherited from the base class. All right. Where he is gonna say, well, the title, in this case, let's say the title element and body element, say title element, which is title, right, and body element dot text content, right. It'll be is the body. All right, and I'm assuming that this is something that is expected. Okay, so we need to actually find a way to, once we already get these elements, return them, right? Or append them. So, interesting. Or to append them. So let's go to think about this. Now that we change these elements here, the property of the card title and the body, we need to find a way here. Since now this whole is a copy of this, okay, and we are modifying is the copy itself, we need to find a way to actually return that, you know. And that's what happened, and that's when we need to actually clone that. And that makes a lot of sense. And that makes here is a lot of sense. So here in these articles, we need to actually is get a copy of that, or clone this. Clone makes sense. Clone node to true. All right. And then get me is the first element child. That makes a lot of sense. So instead of actually call this article, we're gonna call this car, what we're gonna get from the template. That's right. And now we can actually, since this is a copy of that node, all right, and then we can modify the reference of this car. Okay, now we can use return the car. Okay, because what we're doing is just modifying is the reference of this car. That's pretty fucked up, bro. And now this will work as expected. So if we run here, for example, how do we run here the browser? How do we spin up a browser here? VS Code. No. How do I spin up a browser here? How the F extension. Okay. So perplexity. How to spin up a browser tab from CodeSandbox. And the run button. What is the run button? I don't see that. What is the run button, bro? What is the run button, bro? Yeah, what is the run button, bro? Oh, okay. And there you go. Exactly. It's now actually loading is that. So we can add some CSS style for that. Yeah, let's go to add some CSS class for that. Ooh, I don't have that CSS class. I think those CSS class are on the here. Oh, but this is the slides.
So what is the DOM API? Various elements on a browser, for instance, React, Angular, or Vue. But there are cases where we actually need to use the DOM API. And one of that is when you're building some low-level library that works with virtualization or some DOM management. Also, it's used when you need to create some generic components that can be ported to any library or framework. It can be video player or chart engine. And also, for instance, you are building your portfolio website and you want to minimize the blueprint of your application by not importing too many libraries. So this way you can just use the DOM API and your app will be lightweight. So this section will give us a quick refresher on how to use the DOM API. So first, let's overview the objects that are available to us and how can we use the DOM API. So the first global object that we are all aware of is the window. The window is a globally accessible object, so you don't need to import anything. The next one is the document. The document represents HTML element, basically the page that we are currently rendering. And the document can be accessed through the window or directly by referencing this as a global object. Then we have some quick access links that we can use on the document. It's a body and head, gives you us the body tag and head respectively.
Yeah, the DOM begin.
Now let's go through the class hierarchy. All the elements on the HTML page are represented by HTML element, but apparently the HTML element doesn't have any DOM API assigned to that. The DOM API is actually assigned to the element prototype. So why is that?
So
because the DOM API can actually work not with just HTML, so we can use SVG element or XML-like things. So that's why the DOM API is on the element prototype instead of HTML element.
And then the
and we also have the node. The DOM is a tree, and somehow we need to access the tree properties. So that's why we have a special class that's designed to represent that tree, and this is the node.
Okay, that was very interesting, my friend. Oh my god, that was very interesting. Very interesting. Yeah, completely, bro, completely. So what we actually experience is that in real time is like how you actually need to create is this how you're going to interact with these low level libraries from the DOM and how they move on, how they evolve over time to actually provide you better ways or convenient ways to manipulate or interact with this DOM. So a lot of the time you are need to do that for integration, usually for that. Okay. A lot of the time is usually for that. Mm-hmm. God damn, this clone aspect to me is like, yeah, but how can I get a reference, but I want to get a copy of that, you know? I get this copy from the template, which is quite interesting because after all, template content, as you can see here, you know, template content, as you can see here, is exactly content without an equivalent. So the content property here, which comes from the HTML template element, is a document fragment, and this document fragment, because it's now part of the node, this abstract class, is this actually allow you to clone that, or this clone property comes from the node? That's clone node. Holy F, bro. So what you're doing is you're saying, hey, there is a several method here from the node, alright, that actually is, instead of actually working directly with the reference, you just create this clone node. Why is that? Because you don't want to modify as the real instance, or you don't want to work with the real instance, or you don't want to have access to that real instance. You just want to create a copy from that. Mother F. Holy moly, bro. Oh. Okay. That was very interesting as a way to actually see in step by step how you're going to create this simple exercise. Pretty simple, right? Pretty simple. Yeah, pretty simple. The example to call this is the DOM API. So the DOM API. Yeah. See, it says DOM API. DOM API here. DOM API and fragment. Efficiently add elements to the DOM without triggering too much reflow. Without triggering too much reflow. Only the last by get the element, get the template, clone the first element, or get a copy of that, get a copy of get a copy of the first element, so clone it, access or query the elements needed, update the content of those elements, the title and the body, holy shit, and return the copy, bro. That's pretty fucked up, bro. Pretty fucked up, bro. Pretty fucked up, bro. Pretty fucked up. Pretty fucked up, man. I would like to create now I would like to create a fork here. Okay, how can I now push this? God damn. All right. Installing the container. Okay, so it create a container, then it runs that, now it's host that, and then it connect to that. What? It create all of this in all of this node model. So right now I'm accessing to my repo, right? Okay, so if I say run, okay. Okay, it's because now it's locally running here. Exactly, which is in this. Okay. That's interesting with CodeSandbox. And powerful. But again, it's way much more faster. This is for doing small tests. You know, for doing small tests, pretty good. Pretty good. It's like awesome. For doing small tests, awesome. Now I want to create is a new branch here that'll be called is now the observer intersection API. Okay. All right. The intersection API, that's right, on the index here. Now it's this one, where the whole point of this is to see how we can create now is this elements that we're going to append that. We're gonna append is a series of elements after that, right? So here the code changed a little bit. Okay. This was just an introduction of how you can actually is for manipulating is the DOM in this low level, how you can now actually is to create those elements as much as you need it, and then append that when is required, right? That's quite interesting. That's quite interesting. So, when it comes, now that we look at the basics, so now when it comes to actually is understanding how we're going to what are the most use case when we need to build, especially as a UI developers. What are the most common user interface interactions needed to cover specific business use cases? So we got now is the observer API, where unlike the traditional event driven, it now has a particularly subclasses to cover each one of those cases. So you have now the observer API for the intersection, the mutation, and the resize. So the intersection actually cover is things like virtualizations or analytics. So you want to know is when the user is so what are the most common elements that a user is navigating to or is scrolling to, right? Or for how long a user is now is stayed in a particular component, right? You want to keep track of that. Virtualization, lazy components, analytics, and dynamic elements. Okay, this is for intersection observer, and we have the mutation observer, which is give us the ability to keep track DOM change. Useful, very useful on text-rich editors or drawing tools. So, for example, Notion actually used heavily on that. That's interesting. And the resize. So, for example, for graphic libraries, okay, or charting tools, or drawing tools, or for adaptive design. So far we have looked at the intersection observer. How can we do that? All right. And a particular example of that where we're going to now take a look at that example.
Okay, so this section will be, there is a you can find the final solution branch. So basically the prefix is end instead of begin. Okay, let's traverse to, let's go.
Observer API. What in the emphasis? Use cases, intersection, mutation, and resize. Okay, this is the exercise, whatever it is. This is the exercise. Exactly. There you got it. I want to be more specific to that. The intersection begin. The other is the mutation end. No. Oh, because it's the way how they put this. Okay. Where is the exercise here? Oh, the exercise here, right? But with the intersection observer, okay, we are now something that I find out. Yeah, goddamn. Browsers are scary, man. Browsers are scary of what in the F are you doing? So, in here, we are going to copy that, especially here from the intersection observer, and some utils as well, like db, makes sense. Okay. Utils like db gs, where we copy this, all of his code. Alright, it's a way to generate particular entries for that. Okay. And then when we want to import this, which to me was quite interesting, you know, to me was like quite interesting. To me that was quite interesting. Why is that? Because the browser, when you try to reload that without a dev server, is the browser says, "Hey, no, know what you're doing. Hey, I don't know what you're doing." The browser scared the hell out of this. It's like, it's like, hey, what in the F you think you're doing? And if we want to run this, which is looking at this and configure, can we remove this? Now what if I want to stop that? No? There is no way for actually to me to reset that. That's interesting. There's a bug there. And is this one, right? So this actually works as expected, right? Bottom observer, but why is this? Oh, exactly, it's not loading the proper style as expected here. I think I should leave this anyway. And now let's gonna call this as index. Alright, so once you save this, when you reload the preview, alright, now you can see it's working as expected. Okay, alright, so unlike the other, so now that we already creating clone that, alright, now that we already creating clone that, this is also a way of how you can now assign tuples on the JavaScript, which to me is beautiful. Alright, but for small things, for small set of things, here's what we're going to define is the mutation, the intersection observer. Okay. I'm gonna leave that. I'm gonna make a pause here right now to do that. So that'll be all for this video. Take care. Bye bye.